Hello class, welcome to our first lecture. In this video, I wanted to start off by explaining how my online lectures usually work and in my design, and then we'll get right into some of the introduction to functions. So first of all, I've done a little bit of updating to our Blackboard course and added a couple navigation panes on the left. You should always be able to find the lecture videos just by going to Canvas and clicking on lecture videos. And it should pop up with a page like this. And the left-hand side should be the videos organized by each of the little boxes on the schedule. Basically, you know, each couple lectures should be done before the next class period. And you know, as I said with the schedule, try to do your best to follow that. And right now there's nothing here because I'm currently working on these. But this is basically what it will look like. And each lecture will have some accompanying notes, either like a document or slides or something, usually in the form of a PDF. But those documents are what I'm always going to for my examples that I'm doing in the videos. And usually, well, what I typically recommend is that you download these lecture notes, print them out in a perfect world, and work on them as I'm going through the videos. So I'll do some of the examples sometimes I'll leave them as exercises, but it's sort of a walk through the major concepts that we're going to go through in those videos. And they should always be organized by the section number in the book, which should be the same as the textbook and what appears in the homework. Also, as you're working on each lecture, what I recommend is going into and working on the homework as you go. So each section will be organized into one, two, or three sections of the book. And as you finish one set of videos, I recommend going into the My Math Lab. And again, you can access that from the homepage on the left. I've added a link to there as well, My Lab of Mastering or My Math Lab. And you should be able to go directly to your assignments from there and basically just work on the corresponding section as you go. Now, my Math Lab assignments are not due at the exact same time as the lecture. So like, for example, our first lecture I'm assigning for Thursday, which would be these first couple assignments. And notice I give you more time to work on it. So it's not actually due till our next class meeting because I want you to definitely have it done by then. But I recommend that you do it at the same time as you're watching the lectures on Thursday instead of waiting till exactly this time to do it. And sometimes assignments will be due at the end of the week, like on a Friday or something. So you can always check when stuff is due by going into My Math Lab. And that's definitely what I recommend, going in there at least, you know, a few times a week to see and make sure you're caught up. But as I said with the design, it should always be corresponding to the schedule. And each scheduled lecture and section of the book that we're covering for online class time, there will be homework with that. So you can just expect it to be there, and it should always be due in around a week time frame. Not, you know, that there's a little variability, and I prefer if you do somehow miss a deadline for the homework, my philosophy is better late than never. But anyways, that's the basic design. And basically this will be populated with these videos, and you know, I've designed them in a way where if you go through them in order, things should be making sense. And if you are ever running into trouble or the videos aren't making sense or something is missing, that's where office hours, class time come into play. So just drop into my office hours, shoot me an email, whatever is easiest for you. But please let me know if you're ever having trouble or if something's just missing. But anyways, let's get on with the introduction. So our first chat, I'm gonna jump around a little bit in our book because I'm not too fond of the way it's organized. It's not a big deal, and the way I've designed it should flow pretty naturally. But we're gonna start in chapter 3, which is an introduction to functions. And just to sort of give you a heads up on how our book is organized, chapter 1 is a pretty big review of elementary and intermediate algebra. I'm assuming that you guys, because the prerequisite for this course is intermediate algebra, have some pretty good algebra skills. We will review stuff as we go, so I'm not going to totally leave you in the dust if algebra, it's been a while, or if it's not your strong suit. But that is the assumption that I'm operating under. And, you know, it might take a little bit of warm up and review to get back into the swing of the algebra that we're using. Anyways, we're going to start in chapter 3. And then we're going to go back into chapter 2 and 4 and do them kind of at the same time, because our book kind of does the same thing twice, which I think is kind of strange. So I'm just trying to skip a lot of the more boring review stuff, just kind of start in on the most important stuff, and we'll kind of weave our way back and work on some of the older sections as we go. And again, the organization you can find in the schedule. So if you're ever a little bit lost in terms of the book, I do apologize that it's a little bit oddly organized, but anyways, I think it will be easier this way. So chapter 3 is all about functions. So the first section, we're going to look at an introduction and talk about some basics, getting into some graphing and other properties in these first few videos. But to begin with, a mathematical function is basically just a relationship between two quantities, and it's something that we can be very familiar with in the real world, because most relationships are functions. So there's what's called a relation and a function. A function is a direct correspondence, where it's like if something happens, there's a direct relationship from that. It's like cause and effect. And often we refer to the variables in such an equation as dependent and independent variables. And you know, a function is a type of mathematical equation. But basically, it's defined to be a correspondence that assigns each element from one set into another. So like in a mathematical set, just a group of things. Basically, let's just jump into an example, because I feel like I'm struggling to explain the basics of what I'm talking about. But basically, one set of the function is called the domain, or the set of inputs, and the range is the set of outputs, where that would be like cause and effect. And it would be the relationship between one group of things and another. So let's say the domain of our function is set to be 2012, 2013, 2014, 2015, and so on. And the range is set to be Giants, Red Sox, Royals, Cubs, and Astros. And so if you're just looking at these two things, and this is not a mathematical function, it's just I'm trying to illustrate a real example of the correspondence. Basically, we can see that, well, you could probably guess that on the left-hand side, the domain is a set of years, and the range is a set of baseball teams. If you're not a sports person, maybe you don't really know this correspondence, but basically, you could then, the question I would typically ask if we were in a live class is, does anyone know what this function is, or what is this correspondence? And you might guess maybe it's the correspondence between who won the World Series in what particular year. So we could design a function which would take the input, the year, and give us an output, who won the World Series. And we could call that function f, or typically we use a letter to describe our entire function. And the function would often illustrate a phenomenon. Like in math, it might be, well, take a number, multiply by 4, and add 3, and now the result would be your output of the function, where the input is the input number. Whereas in this case, our function is not like a mathematical calculation, but instead it would take the input, which is what is the year, and grind through that and tell us, well, what is the output, the winner of the World Series in that particular year. And sometimes we use what we call an arrow diagram to illustrate the correspondence. We typically don't do this with mathematical functions, but basically the domain is the set of inputs. So in this case, we're given these values, 2018, whoops. And the range is the set of baseball teams. And basically, we would draw an arrow which would illustrate the correspondence from each element of the domain to each element of the range. So, and this is something you probably don't know, and I hope I remember this correctly, but in 2012, the Giants won the World Series. In 2013, the Red Sox. 2014, the Giants won once again. 2015, the Royals won. 2016, the Giants won again, I think, or was that the year the Cubs won? And so, you know, I could always go double check this relation, but there was something about how, you know, list of World Series winner. And let's see who we could come up with. So it was the Cubs in 2016, the Astros in 2017, and the Red Sox in 2018. Okay, so yeah, I had forgotten. I had to double check. But I think you get my point in that we have a certain correspondence between two things. That's the idea of a function. Now, the whole point of this illustration was to illustrate a few things that are allowed in a function and things that are not allowed. In a function, again, in a mathematical function, every input has to be what we say well-defined. If there is an input, there has to be an output. Like, for example, one thing that wouldn't make sense for the domain would be, say, for example, 1402. Because in 1402, baseball didn't exist, as far as I know, and so we don't have a World Series champion, right? It's like if we were to throw that into our function machine, a machine that calculated and ran through and found the answer, we wouldn't have a way of doing that because it just is invalid. And so we'd say that is not part of the domain. Or another, you know, other types of numbers that would not be in the domain, say for example, 2012.3, like a decimal number or a fraction, or certain types of numbers might not make sense in certain functions, and certain other types of numbers might make sense. Or of course, 2022. That is something we don't know yet. So, and we're obviously in our course, we're going to be focusing on mathematical functions as opposed to functions like this, where you can take the domain, run it through a formula, find the answer. But baseball is a little bit more complicated, and there's not a simplistic formula which would tell you who's going to win the World Series. There are ways of predicting and statistical models that can give you more likely outcomes and less likely outcomes, but you know, we don't really know until it happens. And sometimes there's other things that influence winning, and scandals like the Astros in 2017 was a pretty big scandal with that win. So would you put an asterisk on it or whatever? Not going to worry about that. And also thinking about the range. So the domain has very specific conditions sometimes where certain numbers are not allowed. Same thing goes for the range. Now this is not a mathematical range, because usually in a mathematical function you take a set of numbers and the output is another set of different numbers with the dependent on f of x. But like in this case, we'd have the range should strictly be set of baseball teams. Like you wouldn't want to put, for example, the Lakers in there. It doesn't make sense because they're not going to win the World Series anytime soon, at least. Or, you know, you wouldn't want to put 5. That wouldn't make sense either. Or one other thing that will never be in the range of this particular function would be the Padres. And this is a San Diego joke because I'm a San Diegan and the Padres are always nice and embarrassing. And this was a really, really elaborate setup at that joke. But anyways, I think you get the idea about domain and range. Also, this, like when we're looking at this isn't necessarily the whole function. This is just a little snippet of the function to help us understand this relationship. But a lot of times there's other numbers, right? Like there could be 2019, 2020, or values going into the past, which, you know, if we extend or open up that domain, it would also open up the range and add more teams into it. But again, never gonna be the Padres.